Good evening. I think we have to solve four MCQs, rather three MCQs, and then we'll be solving remaining sums on the topic induction and binomial theorem. Eighth MCQ: in the expansion of 3x plus 2 raised to 4, the coefficient of middle term is. In the expansion, there are 5 terms. So third term, T3, is the middle term. That is T2 plus 1 because we have formula for TR plus 1. So it is 4C2, 3x square, 2 square. Now 4C2 is nothing but 6. 3 square is 9, 2 square is 4. So 216. So correct option is D, Delhi, for sum number 8. Sum number 9, the coefficient of 8th term in the expansion of 1 plus x raised to 10. So let us find T8. It is T7 plus 1. It is 10C7, 1 raised to 10 minus 7. That is 1. And that is why I have just written 10C7. It is 120. Correct option is B, Bombay. Last MCQ. If the coefficient of x square and x cube in the expansion of 3 plus ax raised to 9 are the same, then the value of a is. Now this is the general term. Now coefficient of x square, for that r has to be 2. I have directly written that 9c2 3 raised to 7 because 9 minus 2 is 7 a square. What is coefficient of x raised to 3? For that r must be 3. Simple. So 9c3 3 raised to 9 minus 3, that is 6 a cube. 9c2 is 36. Now 3 raised to 7 3 raised to 6. That is why I have written 3 here. Now a square a cube, so a on RHS, 9c3 is 84. You have to find that. So a comes out to be 9 by 7. So the correct option is D, Delhi. Now second part, 11th sum, prove by method of induction. First one, log of x raised to n to the base a equal to n into log x to the base a, x greater than 0 and n is a natural number. Let Pn denote the given statement. Step 1, for n equal to 1, what is LHS? Log of x raised to 1 means log x to the base a. What is RHS? 1 into log x. Of course, I have to mention the base a. Log x to the base a. Yes, same. LHS equal to RHS. That is P of 1 is true. Second step, let P of k be true for some k belonging to n. That is log of x raised to k to the base a equal to k into log x to the base a, x greater than 0. Number 1. Third step, we now prove that P of k plus 1 is true. That is to prove log of x raised to k plus 1 to the base a is k plus 1 into log x to the base a. Begin with LHS. This is LHS as per laws of indices. What is x raised to k plus 1? It is x raised to k into x raised to 1. Log mn is log m plus log n. It is better if you mention that log. Log mn is log m plus log n. But from 1, what is log of x raised to k? K log x plus log x. Take log x common to get k plus 1 in bracket. Of course, I have to say this is nothing but RHS, and then I have to say therefore P of k plus 1 is true. Now fourth step, from above 3 steps and by the principle of, actually we have to add one more word, by the principle of mathematical induction, P of n is true for all n belonging to capital N. That is, we have denoted this by Pn, but original result is log of x raised to n to the base a is n log x to the base a. X greater than 0, n is a natural number. Now, third part, second for homework, third part, let Pn be the result 5 raised to 2n minus 2 raised to 2n is divisible by 3. Okay, for all small n belonging to capital N. For n equal to 1, we get 25 minus 4, that is 21, which is divisible by 3. So P of 1 is true. Let us assume that for some k belonging to n, P of k is true. That is 5 raised to 2k minus 2 raised to 2k is divisible by 3. Means what? Do we say that 13 is divisible by 3? No, because 13 upon 3 is not a natural number. But when we assume that this is divisible by 3, by that we mean 5 raised to 2k minus 2 raised to 2k when divided by 3 gives m, which is a natural number. Cross multiplication gives 5 raised to 2k minus 2 raised to 2k equal to 3m. So 5 raised to 2k is 2 raised to 2k plus 3m. Don't write, just listen to me. You have to write the solution after the lecture. Now we have to prove that P of k plus 1 is true. That is to prove 5 raised to 2 into in bracket k plus 1 minus 2 into 2 raised to k plus 1 is divisible by 3. Again, laws of indices. So this is 5 raised to 2k plus 2 minus 2 raised to 2k plus 2. That is 5 raised to 2k into 5 square minus 2 raised to 2k into 2 square. Oh, 1 minute. Yes. Now, what is 2 raised to, where were we? Yes. So 5 raised to 2k is to be replaced by what? 2 raised to 2k plus 3m. Yes. So 25 into this. 5 square is 25 and we have replaced 5 raised to 2k by this. Right? Raised part as it is. Now open the bracket. That gives us 25 less 4. So 21 2 raised to 2k plus 75m. Take 3 common to get 3 into in bracket 7 into 2 raised to 2k plus 25m. Note that this part in a bracket is natural number which is multiplied by 3 and therefore this is definitely divisible by 3. Okay. 1 minute. What is happening? Right? So P of k plus 1 is true. And rest part, you know that in step 4 we say that from above steps and by the principle of mathematical induction, P of n is true for all small n belonging to capital N. Okay. Yes. So this is the result. That 5 raised to 2n minus 2 raised to 2n is divisible by 3. Sum number 12. If the coefficient of x raised to 16 in the expansion of x square plus ax raised to 10 is 3360, find a. So first we find general term in the expansion. This is 10cr, x square raised to 10 minus r, ax raised to r, 10cr. Now a raised to r is constant. So we take this outside the bracket. We want a single term in x so that we can equate its index with 16 because we want coefficient of x raised to 16. Simple. And that is why x raised to 2 into 10 minus r, there is one more term in x raised to r. We add indices, so plus r. Now this is in x raised to 16. Equate index with 16. So 20 minus 2r plus r, that is 20 minus r equal to 16. So r equal to 4. So what is the coefficient of x raised to 16? For r equal to 4, 10c4 a raised to 4. But it is given to be 3360. Now 10c4 is 210. So 210 a raised to 4 is this. So what is a raised to 4? 3360 upon 210, which is 16. Take fourth root. You have to consider both the signs plus minus. So the answer is plus minus 2. Sum number 13. If the middle term in the expansion of x plus b upon x raised to 6 is 160, find b. There are 7 terms in the expansion. So middle term is fourth one. Now this is general term. So fourth term is 6c3 x raised to 6 minus 3 b upon x cube comes out to be 20 b cube. But it is given to be 160. So b cube equal to 8. So don't say b equal to plus minus 3. So b equal to 2. So the correct option, I'm sorry, this is not an MCQ. So b equal to 2. Sum number 14th. Actually, This was asked as MCQ also. You can check that. 14th one, if the coefficients of x square and x cube in the expansion of 3 plus kx raised to 9 are equal, find k. So this is the general term 9cr 3 raised to 9 minus r into k raised to r into x raised to r. Now what will be the term in x square? For that r should be 2, but we are interested in coefficient only. That is why I have written 9c2 3 raised to 9 minus 2 k square. For a term in x cube, r has to be 3. So what will be its coefficient? 9c3 3 raised to 9 minus 3 k cube. Now 9c2 is 36. 9c3 is 84. Now this is 3 raised to 7. This is 3 raised to 6. That is why I have written 3 k square k cube. So k. So what is k from this? 36 into 3 by 84. That is 9 upon 7. This is an important type. Sum number 16. Show that there is no term containing x raised to 6 in the expansion of. Now, first method is donkey method. Index is 11. So just expand to get 12 terms and then say, see, there is no term in x raised to 6. But we will be using shortcut method. Find out general term tr plus 1. It is 11cr x square raised to 11 minus r minus 3 upon x raised to r. We want a single term in x. So 11cr minus 3 raised to r, a raised to m raised to n, a raised to mn. So x raised to 22 minus 2r. 1 upon x raised to r is what? X raised to minus r. We add indices to get this. Okay. Now for a term in x raised to 6, index of x must be 6. Equate this with 6 to get r equal to 16 by 3. Now many students say this is wrong because r is a natural number. No, r can be 0 also, because we find t r plus 1. So for the first term r is 0. So you have to say that r is a whole number. Okay. So there is no term in x raised to 6 in the expansion. Write the solution. Actually, in sum number 17, type is the same, that show that there is no constant term. So same logic, obtain general term and say that for a constant term, index should be 0. But if you equate index with 0, you get, maybe I think in that case you get negative value, which is absurd. So there is no constant. 22nd, find the approximate value of 1 upon 4.08 up to 4 places of decimals. What is 1 upon 4.08? It is 4.08 raised to minus 1. That is 4 plus 0.08 raised to minus 1. Within bracket take 4 common. So 1 plus 0.08 upon 4 is 0.02. Now this is 4 raised to minus 1 into this. 4 raised to minus 1 is 1 by 4. Now 1 plus x raised to n is 1 plus nx plus n into n minus 1, that is minus 1 means minus 2 upon 2 factorial into square of this. I haven't written the remaining terms because we have to find answer up to 4 decimal places. Simplify. You get 1 by 4 into 0.9804, which is 0.2451. Correct up to 4 decimal places. Sum number 23, just listen to me. We have already solved one sum of this type, but here we will be discussing solution using two different methods. Find the term independent of x, that is constant term, that is term in x raised to 0 in the expansion of 1 minus x square into this. See, if only x plus 2 upon x raised to 6 is asked, then we can easily get the answer. But here it is, if you open the bracket, 1 into and then minus x square into. Okay. See, 1 minus x square into this equal to x plus 2 upon x raised to 6 minus x square into this. Why? Just open the bracket. 1 into this, same, minus x square into. This is number 1. Now, general term in the expansion of a plus b raised to n. So for this only, what is general term? 6cr 2 raised to r x raised to 6 minus 2r. For term independent of x in x plus 2 upon x raised to 6, r has to be 3 because index should be 0. So what is that term? it is nothing but, see, r has to be 3. Okay. Now, for the term independent of x in x square into this, the only difference is here you have to consider one more term x square. So that index again, if we equate with 0, we get r equal to 4. This means there are actually two terms for r equal to 3 and r equal to 4. So it is what? It is 6c3 2 cube minus 6c4 2 raised to 4. Simplify that. That gives you 160 minus 240, that is minus 80. So this is the first method. Now second method. In the last sum of this type, we use this method. 1 minus x square into x plus 2 upon x raised to 6. So expand, there will be 7 terms, right? Now the term independent of x, 1 into c, this term is independent of x. Why? Because there is no x, right? And minus x square into this is again independent of x. Why this is so? Because x square into 1 upon x square is 1. But see, this is minus, and that is why minus 6c4 into 16. Same. Of course, we must get the same answer. Otherwise, there is no point in saying different method if we are getting different answer. Right? So minus 80. 24th sum, a plus bx into 1 minus x raised to 6 is 3 minus 20x plus cx square plus dot dot dot. Then find ABC. See, we need not find terms after x cube in the expansion. For the simple reason, we are interested in terms up to x square only, right? So 1 minus x raised to 6 is 1 raised to 6. Terms are alternately positive, negative. So minus 6c1 x plus 6c2 x square. That's it. Now 1 is 1, 6c1 is 6, 6c2 is 15. Now we have obtained three terms. Which is the constant term? Open the bracket, a into 1 a. Next term is in x, a into minus 6x, so minus 6a. But bx into 1 is bx. So if you take x common, minus 6a plus b is coefficient of x. This is not at all difficult. You should understand this. Now we are interested in finding a term in x square. See, bx into minus 6x is minus 6b x square. See, minus 6b. Now a into 15x square is 15a x square. Yes, take x square common, you get 15a. But this is given to be 3 minus 20x plus cx square. So a must be equal to 3 minus 6a plus b must be minus 20. So that gives me b equal to minus 2. And what is c? Coefficient of x square, 15a minus 6b. But a and b are already obtained. Substitute the values to get c as 57. So final answer, a equal to 3, b equal to minus 2, c equal to 57. 25th sum, the third term of 1 plus x raised to n is 36x square. Find fifth term. Okay. So we must first obtain n. We know that general term is NCR, 1 raised to n minus r, that is 1, x raised to r, right? So third term is NC2 x square. It is given to be 36x square. So NC2 is 36. From that I get n equal to 9. Now for fifth term, r has to be 4. So what is fifth term? It is T5, which is 9C4, 1 raised to 9 minus 4 into x raised to 4. So it is 126. What is that? 126 x raised to 4. Okay. 26. Suppose 1 plus kx raised to n is 1 minus 12x plus 60x square and so on. Find k and n. So we are interested in first three terms only. So 1 plus x raised to n is what? 1 plus nx plus n into n minus 1 by 2 factorial. I have used that form. I have written only three terms because on RHS three terms are given. So clearly nk is minus 12, n into n minus 1 upon 2 factorial, which is 2, into k square is 60, because this is coefficient of x square. Okay, now nk is minus 12, so what is k? Minus 12 upon n. So I replace this k, see the cursor, by minus 12 by n. Actually it is k square, that is why I have directly written 144 by n square. Now 272, 1 n gets cancelled, so 72 n minus 1 upon n is 60. Cross multiply but divide by 12, so 12 6 are 72, 6 into n minus 1 is 5n, so that gives me n equal to 6. So what is k? Minus 12 upon 6, that is minus 2, right? So all the sums from the textbook are over. Tomorrow we'll be solving additional sums on this topic, which are not given in the textbook, and then we will be doing miscellaneous exercise from the topic functions.